What is deduction? A deductive argument is a type of inference where the conclusion logically follows from the premises. In other words, it is impossible for the premises to be true and the conclusion to be false at the same time. For instance, all men are mortal, Socrates is a man, hence Socrates is mortal. This argument is banal and simple, and we can see instantly that it is valid. But how do we go about when we have a more complex argument and want to figure out whether it's valid or not in a more systematic way? Simply through truth tables. We have gone through the basics of truth tables, but now let's use them in a more practical way. There are 3 simple and classical variants of deductive arguments that I want to go through in today's episode. Firstly, Modus Ponens. Secondly, Modus Tollens. And thirdly, Disjunctive Syllogism. Let's begin with the first one. This is the structure of a Modus Ponens argument. If P, then Q. P, therefore Q. But as always, let's make it a bit more concrete. Let's say that P means there is sugar in the cookie, and Q means that the cookie is sweet. So here, the whole argument can be translated to: if there is sugar in the cookie, then the cookie is sweet. There is sugar in the cookie, therefore the cookie is sweet. Is this valid? Well, yes, but let's look at the truth table to see if it is. So let's begin to check the first premise. It's true here, here, and here. And then we check the second premise. It's true here and here. But as you can see, the only place where both the premises are true is here, and on the very same row, the conclusion is true as well. Hence, the argument is valid. If the conclusion here would have been false, the argument would have been invalid. But let's take another argument instead, which looks very similar. If P, then Q. Q, therefore P. And same thing here, let's translate it. If there is sugar in the cookie, then the cookie is sweet. The cookie is sweet, therefore there's sugar in the cookie. This one is a bit fishy, right? There is something wrong with this argument. Let's check out the truth table once more. Our first premise is true here, here, and here, just like before. But then the second premise is true here and here. So we need to look at these 2 rows here. Here in scenario 1, the conclusion together with the premises are true. So far so good. But here in scenario 3, both the premises are true, but the conclusion is false. What makes an argument valid is when the premises necessarily makes the conclusion true. Hence, the argument is fallacious, since there is a possibility for both the premises to be true at the same time as the conclusion is false. In other words, there could be something else rather than the sugar that makes the cookie sweet, right? This fallacy is sometimes referred to as affirming the consequent. So now, let's move on to Modus Tollens. If P, then Q, not Q, therefore not P. So if we translate this argument, it would sound something like this. If there is sugar in the cookie, then the cookie is sweet. The cookie is not sweet. Therefore, there is no sugar in the cookie. That sounds like a valid argument, right? Let's check the table. Here is a slightly bigger table where I included the negations. Then we begin by checking the first premise. Same thing here. The first premise is true in these 3 places. And then the second premise is true here and here. But here, both of the premises are true at the same time as the conclusion, and we can't find any other row where both the premises are true but the conclusion false. So, the argument is valid. Let's also take this argument that looks like a modus tollens. If P, then Q, not P, therefore not Q. If there is sugar in the cookie, then the cookie is sweet. There is no sugar in the cookie, therefore the cookie is not sweet. This is a fallacy, and it's commonly called denying the antecedent. So if we look at the truth table, we have the row here where both the premises are true, but the conclusion is false. Hence, it is a fallacy. Now on to the last one, disjunctive syllogism. Let's take this argument. P or Q, not P, therefore Q. Here, I think we should switch the variable's meaning to make it sound more reasonable. So, I will give you a hamburger or I will give you fries. I didn't give you a hamburger. Therefore, I gave you fries. This one might sound a bit fishy, but let's look at the truth table to see if it's valid or not. P1 is true here, here, and here. P2 is true here and here. But here, both of the premises are true at the same time as the conclusion, and here the conclusion is true as well. Hence, the argument is valid. Now you know the basics of utilizing truth tables to analyze arguments. The logical implication that we have used a lot in today's episode is actually redundant. In other words, we don't really need it, but that will be the subject for another episode. So make sure to subscribe if you want to learn more about that.